made a half gallon, so like one of those like jug kind of this size, of fresh orange juice on a Saturday evening for Sunday's breakfast. In the middle of the night, Liesel, who's the oldest Von Trapp, we're doing the Von Trapps here, if you didn't catch on. So Liesel got really thirsty. She's that one that does the go I am 16 going on 17 song and dances around the gazebo. Yeah. You haven't? You are missing out on what? The Sound of Music. The one with all the little kids and the nun becomes their nanny and then they get married and then they escape Nazi Germany. You are uncultured, and we need to watch the movie.
Really?
It's a movie. No, not tomorrow. I don't have it on TV. Alright, Liesel got really thirsty. Hold on. Liesel got super thirsty and went down to the kitchen and drank half of the orange juice. Then she didn't want her family to know because she didn't want them to know that she drank all the orange juice that Maria squeezed. So she refilled the pitcher with water. Right, so she drank half the orange juice, she filled it back up with water so no one would be able to tell the difference. Well, not long after Liesel, Friedrich woke up, drank half the pitcher of orange juice, and then also had the same thought, I don't want my family to know that I drank all the orange juice, so he filled it back up with water. Oddly enough, every single Von Trapp child did that night.
By the time they got to Gretel, she didn't notice that it was supposed to be water there.
Yeah, she was like this big, so probably not. Alright, so at 0, before anyone started drinking the orange juice, how many ounces of orange juice were in the jug? 64. Now after Liesel drank some, how much of the orange juice did Liesel drink? Half of it. How much orange juice would be left in the pitcher? 32. She refilled it up, but there's still only 32 ounces of orange juice. So after Friedrich, how much orange juice is left? 16 ounces. And then Louisa came, and there's 8 ounces. What about Kurt? 4 ounces. Brigitte? Marta? And how much orange juice? This is gross, right? Like, you're drinking, like, orange scented water? Half an ounce, right? Like, can you imagine drinking, like, a whole pitcher of water with, like, half an ounce of orange juice in it? Right, it would be, you probably wouldn't taste it, and if you did, it would be really gross. Like that, LaCroix water, my sister drinks that, and it's so gross. Oh, those are disgusting. Yeah, I don't know, my sister drinks them all the time.
Wait till say 32 because the half of the water's on top.
Well, like, it would be a mixed in when you pour it in, but 32 of those 64 ounces are orange juice. Then I drink half of that, so then it's only down to 16 ounces, and then 8 ounces, and the rest is water. Yeah, it's really watered down nasty orange juice. So we're going to write a function that represents the amount of orange juice that is left in the pitcher after each of the children sneaks a drink. So first, we have to ask ourselves, what is the initial value? Remember, that's A. We just reviewed that on the board. A for our function is the initial value. And what's the pattern? The pattern is your B, your growth rate. Right? We have A times B to the X. So let's write our function. We have f of x equals. What's the initial value of orange juice? 64. And what's the pattern? What are you multiplying by every time to get the next value? 1/2. So we have 64 times 1/2 to the x power.
Say, that's a lot of orange juice. 32 ounces. 32 ounces of orange juice.
Yeah, that's like four cups of orange juice.
Yeah, that's a lot.
And one.
She was really thirsty.
So I get like
I don't know. It's just, it doesn't make for a fun problem if they just keep drinking water.
Wait, 1/2.
Why are we asking all these hypothetical questions?
Why orange juice? I like chocolate milk.
I don't know. I don't know. Yes, she.
Wait, why?
What?
It's not like if you drink orange juice.
I have no idea. Don't explain.
Why do we use 1/2?
Because every time they each drank half of the pitcher of juice.
Oh.
Right? So it goes halfway down. Alright, now Sunday morning, Georg wakes up, that's the dad, and he's so thirsty he wants to have some orange juice before everyone else wakes up. Using the function to confirm your answer, let's make sure we know how to use the function. How much orange juice will be left after Georg has his fill? So, what number would he be in line of drinking this? 8. So you expect, what do you expect the answer to be based on the table? 1/4. Let's double check using our calculators and the function. This would be 64 times 1/2 to the 8th power. Make sure that you are able to type that into your calculator. Figure out. Just make sure. Sometimes we do funky things in our calculator. How many ounces of orange juice are left? Did you get 0.25 or 1/4? Good. So there is a 1/4 of an ounce. That is not how I spell ounce. Left after your drink. So he's the 8th person to drink orange juice. Now suppose the Von Trapp family had more than just 7 kids, and this pattern continues for 20 people. First of all, would there still be orange juice in the pitcher? Yes, technically there would still be orange juice in the pitcher, right? It would be a very trace minute amount, but there would still be orange juice. Let's figure out how much orange juice there would be. So you're going to find F of 20. How much orange juice will be left in the pitcher? So you have 64 times 1/2 to the 20th power. So how much orange juice will be left? Don't even know. It's a really small number. You're right.
At that point, you must have drink less water.
Yep. Now we have E notation here, right? What does it say?
Wait, because you said it would be nasty.
They're just very stupid.
You said it'd be nasty orange juice. It'd just be water.
Well, at this point, yes, at this point it would just be water. But there's still technically trace of orange. How much, Rachel? What does it say? Yeah, E -5. So this is what your calculator is. Guys, here, almost done. So this is what your calculator says. 6.1 e to the -5. But remember, the e to the -5 is scientific notation. Let's write this as a small number. How many times do you have to move your decimal to the left? 5. How many zeros does that mean you have? 4 zeros. 6.1 ounces. So 0.00006 ounces of orange juice will be left in the pitcher. That's a really tiny amount. Yes, it is basically water, but technically there's still a little bit of orange juice in there. So suppose this pattern continues infinitely. Now I know in real life there's not an infinite number of people, but just go with me here. If it continued infinitely, would there always be orange juice left in the pitcher? Yes, technically yes. However, practically, would you be able to taste the orange juice? No, you couldn't taste the orange juice, but there would still be a trace of orange juice in the pitcher. Okay. Remember doing all this exponential stuff from yesterday? And from Algebra 1, whenever you took Algebra 1. Okay, so what I'm going to have you do today is you're going to need your graphing calculator out. There's just a little bit of practice. The rest of this front and then the back has exponential function practice. I want you to work on this. You can work together. You can work by yourself. I don't expect it to take you half an hour to the end of the period. So what that means is that if you need to retake your quiz from yesterday, or you need to talk about piecewise, or you just have something else you want to do, that is okay. I'm not going to start the new notes. We'll do another set of notes tomorrow, okay? All right. Once you finish your math, you can do your biology.